My name is Mehmet. I'm with the Saskatchewan Food Industry Development Center. It's my pleasure to start our webinar today, and we'll be talking about the introduction to NuWave's innovative drying solutions. In this webinar, I'd like to introduce our guest, Mr. Greg Stromotich, President and CEO of NuwWave Research Incorporated. And basically, we'll organize the webinar as an introduction of the food center capabilities. Then I'll be introducing Greg as the presenter about the overall this cutting edge technology and the overall the providing the new drying solutions for the food industry. So with that, I'd like to start with the webinar. And during the webinar, you can ask any questions through the Q&A box. Please do not use the chat box, but use the Q&A box. And then you can reach out to us with your questions during the webinar, or also at the end of the webinar, we'll have a Q&A session. So the Food Center has been established in 1997 as a contract research and development and innovation agency in Saskatoon. We have strong focus on local crop meat utilization, over 55 full-time employees dedicated to support the agri-food sector in Canada. Over the years, we developed 1,000 products and processed over 1,000 products for over 450 clients serving in all sectors. And we do this work basically through creating, connecting, collaborating within the ecosystem and commercializing and helping the companies. What we do is we support entrepreneurship, reducing capital risk, support commercialization, new technology, research and development with Saskatchewan agricultural inputs. We have a global clientele in Canada, US, South America, as well as Europe, Middle East, Asia, South Asia, Pacific, China, Japan, Australia, and New Zealand. And one of the also reasons for that is not only the food center, Saskatoon is a really major science and innovation technology hub, and so many national labs, AFC, NRC, and so many different groups in Saskatoon. And there's like a major collaboration and ecosystem that we can partner and we can work in the city here. So when we look at our programs, we have the agri-food utilization right in the center. We have product development, extrusion R&D, food safety skills development, ingredient science and technology, food grade crop quality, manufacturing incubation. We are adding a new fermentation and bioengineering program, and we have also the Women in Agri-Food Entrepreneurship Program, which is the awesome program. We support agri-food, women-owned entrepreneurs companies. So we have two processing facilities, a pilot plant in the University of Saskatchewan campus, Agri-Food Innovation Center in Schuler Street. With two certified facilities, we are helping the industry, the companies to produce meat, dairy, processed foods, honey, HACCP certified, BRC certified facility, and in our AFIC center with organic, halal, kosher capabilities, with a wide variety of capabilities, with incubation suites, over 200 pieces of equipment with trained operators. So we have product development team working on different products, scale up, process development, sensory, shelf life, nutritional labeling, food safety, and helping the companies with different funding applications. It's almost like a point of entry for the program. Over the years, we developed very interesting plant-based products, very successful vegan meat products developed for startups to multinational companies. There's a major institutional expertise in custom meat analogs, TVPs, and the plant-based fibers. So if you look at the overall plant protein innovations, there are plant-based ribs to chicken kebabs, calamaris, and different products available within our portfolio. We can also help the industry with different snack clusters, energy bars, bakery, or extruded products. In the incubation processing, we can help the companies with meat, vegan meats, condiments, fruits, vegetables, snacks, dry mixes, cheese and dairy, as well as ready to eat. So there are several production capabilities for the companies as they like to produce these products. So like one example would be an energy bar. We can do about 5,000 bars a day, which we can produce about 25,000 bars a week for the companies based on their needs. In terms of fruits and vegetables, we have low acid, acidic product applications and production capability. primarily on jams, spreads, sauces, and condiments, which we can manufacture different products for the regional and national companies. We can also produce specialty meats, both for meat and alternative processing capabilities, such as bacon, jerky, sausages, pork ribs, burgers, and ham. In extrusion R&D and manufacturing, from proof of concept to market, we can help the companies develop plant-based ingredients, snacks, cereals, texturized proteins, meat analogs, plant-based meat, plant-based pet food, or different extruded ingredients. So these are all the different capabilities we can do. Ingredient science and technology program, we can look at ingredient assessments, technical services, process development, byproduct evaluation, food application recommendations, and shelf life testing. A lot of different capabilities in that area. In the food safety development training, we have online training as well as in-person training in this for HACCP or GFSI programs. We provide certification, auditing guidance, plant-specific training, development and implementation of food safety and the quality programs. We have food crop quality program focusing on primarily with partnering with Saskatchewan pulse growers, working on G/E studies, testing about 3,000 samples of pulse varieties in Canada. We have also engineering and data-driven process analysis program, which we can look at process simulation, sustainability, LCA analysis, techno-economic analysis, as well as the certified process authority, especially in thermal, aseptic, and the low acid foods, so we can help the industry within their needs. Pathfinding services, this is basically connecting all the dots for the startups, for SMEs or larger companies to introduce them to food industry community, educational institutions, and the government organizations. So help them within our industry networks on connections to find the different type of tools and the support or the funding from different programs. Awesome program has been established in 2019 as a agri-food women-owned entrepreneurship starter program for startups. Currently, we finalized our first program, helping about 300 women entrepreneurs in Alberta, Saskatchewan, Manitoba. Just recently received the funding, now looking at adding new capacity from Alberta to BC, Manitoba, Northwest Territories, Ontario, Quebec, Saskatchewan, Yukon, primarily focusing on rural entrepreneurs, rural women entrepreneurs, Indigenous entrepreneurs, under 39, and the newcomers. So that will be the focus of the new program. So the new addition to Food Center is this Advanced Food Ingredients Center. It's a new addition, about 8,000 square feet facility in the south of in our premises as a separate building, which will focus on primarily on synthetic biology, mycelial fermentation, biotechnology, and the conventional fermentation applications, which will serve as a contract research and as a contract manufacturing organization for the industry. Will help startup companies validate their processes at this scale to produce advanced ingredients. So with that, there's a major growing scale-up need in Canada because of the several startups supported by different groups in Canada, from National Research Council to Natural Products Canada, Ontario Genomics, AgWest Bio, and all these startups, they need a place for manufacturing and mainly to scale up, and we'll be helping them with the new facility and also utilizing these ingredients within our Food Center programs. So that's the overall goal. So our partnership with NuWave is basically, this is a really very innovative, cutting-edge drying technology, which Greg will be presenting. Basically, they were really generous, kind enough to house their unit at the Food Center, and we are working on new projects together. It's an R&D scale unit, which we can do small, medium scale production trials. We can do product development on novel proteins, high-fat ingredients, fruits, vegetables on different biomass, nutraceuticals, and novel ingredients. And the overall collaboration is supported by the NuWave Research team for real-time solutions and the troubleshooting. With that, this is my contact information. With that, I'd like to introduce Mr. Greg Stromotich, and then we'll get into his presentation. Thank you, Greg.
Thank you, Mehmet. In 2009, I founded NuWave because of a business need. I'd been seeking high-speed, high-quality drying solution, an alternative to freeze drying. Well, within the first year, we built our first machine, and that machine is still in operation at a customer site. Over the years, NuWave has been quietly solving problems for customers and increasing the sophistication and the breadth of our microwave offering. We provide microwave solutions for industrial applications. Our customers are supported from the idea stage through design, validation, fabrication, and commissioning. We provide long-term support for our customers' operations. By having our own dedicated stainless steel manufacturing facility, we're able to not only build faster, but also integrate custom modifications as required. Although we have our own testing facility, we are delighted to have one of our machines at the Saskatchewan Food Industry Development Center. Their team of experts will support customers in developing solutions for industrial food applications, as well as guidance for incorporating vacuum microwave and dehydration into their processes. I've been asked to give a brief introduction of microwave technologies. Microwaves are everywhere in our daily lives. However, it's important to know what they are and what they are not. The spectrum of electromagnetic energy spans from radio waves all the way through visible light and on to gamma rays, which is what we normally think of as radiation. Microwaves are not ionizing radiation. We are surrounded by microwaves in our daily lives, from Bluetooth to cell phones. Unlike convective drying, where energy is transferred from one material to another, microwaves target the water molecules. Well, they target polar molecules, and water is just a very abundant polar molecule. Air drying heats from the outside of the product, and as that product dries, it loses the moisture on the outside. It creates a barrier to prevent water movement. As drying progresses, the efficiency of the drying decreases as that outside case hardening increases. In microwaves, the application of energy is delivered to the core of the product. The energy turns into water, and the energy turns the water into vapor, which pushes to the surface of the product. Therefore, the outside surface remains wet. This allows the water to wick away quickly and increases the rate of water removal and therefore energy efficiency. In addition to the rate of water removal, the rate of water removal is not dependent on the surface area to volume ratios, which means large food pieces can be dried without case hardening. In the absence of case hardening, there's an increase in quality and a better properties for rehydration. Okay, so that's how microwaves interact with water, but how do they behave in machines? For the sake of simplicity, we have created an image of a conventional microwave chamber, like your home microwave oven. The power is generated in the magnetron and shoots into the resonance chamber. The energy bounces around until it's absorbed. Although we show it as beams in this diagram, it is actually waves oscillating between high and low energy levels. Where two high energy levels overlap, we have an additive effect and the energy spikes. Where a high and a low overlap, we have energy being canceled out. This is commonly referred to as the hot and cold spot phenomena. As a result, products are subjected to very high power levels for short bursts of time, and then no power for other moments in time. This unevenness in power distribution has quality consequences. Further complicating things, as the products dry, their ability to absorb microwave energy changes. We've referred to this as the product drying profile. These changes not only affect the overall heating events, but they also result in disruptions of the wave patterns. So you've got further randomization. Consumer microwaves moves product around to randomize that microwave field in order to attempt to more evenly produce or subject the product to microwave energy. I think it's clear there's a lot going on in a home microwave. However, the take-home message is that the conventional microwave chambers result in uneven heating. This is why some of your dinner is hot while other parts remain cold. Another simplified model. We do microwaves differently. Rather than bouncing the energy around a resonance chamber, we guide the energy directly to the material being processed. We provide predictable, repeatable results. Each applicator controls energy into a specific location, like a tray. Each region is monitored and controlled independently. So as the product dries, the microwave absorbing properties change. We can change the energy applied to match the drying requirements. While others flood their chambers with high power, we apply the energy at different levels at different locations within the same chamber. The net result is we do not overheat the product when drying. We preserve the aromatics and the volatiles, the taste and the flavor. This increases product quality. All our systems have remote monitoring data historians. Sensor feedback, vacuum pressures, and power levels are all monitored. The data is collected and available through trend analysis software that can be used to drive the innovation process. In addition, real-time support is just a few clicks away. Our team can be invited to help you solve problems without waiting for service people to come out to your site. Operating programs can be modified remotely. In addition, recipes can be developed without visiting your site. The iterative development process is accelerated. With all this power, we can customize our machines for different industries. It's really quite exciting. New products come to us every day. The Saskatchewan Food Industry Development Center will be able to help the food applications move from concept through the validation process, and NuWave will be there to support. On a daily basis, we see products from the pet food industry, beverage industry, milks, novel proteins, dairy products. You never really know what's going to come through the door the next day. Companies using the Atlas system at the food center will have a clear pathway for scale-up. Although the Atlas is a tray-based system, its core functionality can be extrapolated to our tumbling processors, our mixing processors, and even our belt processors. Our product offering spans from 6 kilowatts all the way up to megawatt systems. We have systems that operate at 2.45 gigahertz as well as 915 megahertz. Vacuum microwave is disrupting traditional drying alternatives. Freeze drying, although it is a nutrient-sparing process, it relies upon sublimation, the process of converting ice to vapor. It's very slow. In addition to the energy required for drying, there is the energy required to freeze the water that you actually want to remove. As a result, this process is expensive and time-consuming. Installation of freeze dryers takes weeks, if not months. Our vacuum microwave dryers have a much smaller footprint. Our machines can be wheeled through standard double doors with only a few days to install. Processing time is now in minutes rather than hours. Hot air dryers, as discussed, are prone to case hardening problems. As a result, higher temperatures are required, and as the product dries, it becomes even less energy efficient. Initially, the sticker price seems low, but once you look at the true cost of ownership, factor that in, the air dryers are actually quite expensive. Spray drying takes large amount of power and is expensive to install. In addition, the products often have to be diluted to pass through the spray nozzles. So not only is the process using air to heat, but it's also adding additional water, which further increases the amount of energy required and further decreases the energy efficiency of drying your product. Critical to determining which drying technology to adopt is understanding the true cost of ownership. We've prepared this chart to compare our Kraken 60 system to air dryers and freeze dryers of similar size. And by that, I mean similar daily throughput capacities. In determining the true cost of these operations, one should look at the installation price, not just the sticker price, factoring gas fittings, additional ventilation, additional structural floors, requirements for high ceiling, refrigerants, fire suppression equipment. All of this is added on to other technologies that doesn't come onto ours. And with the price of natural gas increasing, electricity has become more attractive. It also lowers the carbon footprint. The efficiency of microwave heating versus air heating make the overall operational costs of vacuum microwave drying even more attractive. Our commitment to service extends well beyond the installation. Our machines have state-of-the-art connectivity, best-in-class protection, a self-generating encrypted private portal back to our support team and to our database. We can analyze the data, monitor the performance of components, recommend service and support schedules, and even tap into our vendor-managed replacement parts to avoid downtime and maximize your returns. When a customer is testing their application at the Food Development Center, they will not only have access to their scientists and experts, but customers can count on the technology support team at NuWave to speed their development process. Thank you. Happy to answer any other questions.
Thanks very much, Greg. Really appreciate it. With that, I like to go back to audience and then start with some of the questions. So couple questions, Greg, about this. We received are these systems only available for purchase in North America, or like do you also deal with like a global support on this?
Yeah, our systems are shipping out all across the globe right now, and today actually one is shipping out into Israel. So we can support remotely as well as locally. So
that remote support is like 24 hours, 7 days a week to support the companies.
Correct.
That's good. What volume can your largest system accommodate?
So the largest systems are our belt systems, and they're built on 100 kilowatt units. And we have an application we're finishing up that would look at 40 tons an hour as a processing material. It's not high moisture, but high volumes can be processed through that.
Good. So in terms of our Atlas system, what's the capacity of an individual tray? So you have more experience, like if you like to talk about different samples.
So the trays are 6 inches by 30 inches in dimensions, and they're about 3.5 inches deep. So it really depends on what your product density is. You can put anything in there from mushrooms or flowers all the way down to liquids and slurries.
Okay. I think somebody asked, Betty asked the last slide up. This is the last slide, I assume, Betty. So that one is done. In terms of the maximum water percentage of the material going in, can you comment on that, Greg? Like what would be the level?
The different machines handle removing water from liquids essentially differently. So a tray-based system, you can go to a high water content as a liquid. We have tumbling systems and drum-based mixing systems, and in that case, you can basically have water in there. Although drying water probably is not the most effective way to use a dehydrator. Yep. The other side of the equation is how dry can you make this? And it really comes down to our ability to roll back the power as it gets very low and there's very little product left in there. And so usually we like to see product get as low as 1% moisture, but typically shelf stability is up at about 5 to 8% moisture.
Yeah. Greg, if I can ask you to share your screen at the last
Sure.
slide. Again, one of our participants is asking that. Okay. Thank you. So going to the next question, how do you remove the moisture from the surface of the product? I mean, in terms of the principle.
So the moisture, the evaporative cooling is always occurring on the outside surface of the product, and that's whether you're doing air drying or whether you're doing microwave drying. So when you're working in a microwave, just heating that water to ambient temperatures, room temperatures basically, and pulling it deep in a vacuum, that water just evaporates right off the surface. And so as the core dries out, the last remaining water is on the outside surface. So it's the last of the water to leave.
Yeah. What about the high moisture product output for the large industrial system? Like, are they like fairly, the level of the moisture getting in the large scale, let's say the Kraken, what's the level that we are dealing there?
So if we were dealing with a liquid and we wanted to, let's say something in the 92% liquid or water constitution of the product, we would recommend actually the Titan series, which has a sort of a mixing agitator in it, in which case you can, it's just the amount of kilowatts you need in order to drive that moisture out in the time period that you need. Typically, we're seeing drying stages like for fruits and vegetables in the 30 to 50 minute range, as opposed to freeze drying, which is a 8 to 12 hour range.
Okay. The overall process, is this more like a batch or continuous for Titan or Kraken?
So for the Kraken is a continuous process, and you can be tray feeding in on the one end and coming out on the far end, so continuously processing that. On the very large scales, we find that sometimes the batch system is just more effective. And so you might have batches of 3,000, 4,000 liters at a time.
Okay, good. One question, we had this conversation a couple of weeks ago. The system at the food center has a flavor recovery condenser coupled with it.
Yes.
The hydrosol, is this a feature available on your production models too? Correct.
Oh yeah, it's available on all of our systems. And depending on what temperatures you're drying at, you can either leave the volatiles in the product, or you can heat the product up enough that not only the water, but the volatiles also come off.
Okay. Going back to that again, continuous process, the microwave, it's continuous in the Kraken and more batch on the Titan. Well, what kind of pressure lock are you using? One question in terms of.
So on the continuous systems, we have an airlock system for the trays as they're going in. And those trays can move in 3 to 4 times a minute. So it depends on how big you need trays and how much volume you need on that machine. But the system as it's designed right now and into production uses the same trays in the Atlas system as we use into our tray-based Krakens.
In terms of product ingredient constitution, is there any limitation to what sort of products that can be dried with this process?
I would have used to have said metals are a bad thing, but we seem to be getting over that problem. Food-wise, I think you can dry most things. It really depends on how microwave insensitive they are in the final stages of drying. So something that doesn't absorb microwaves at all, we may have a challenge at the 3% or below moisture levels.
Mm-hmm. So one question on that, again, hydrosol question, can we adjust the microwave output to preserve the volatile compounds with the hydrosol?
Absolutely. That's the trick. It's that feedback mechanism of controlling the temperature of the product throughout that process. So the individual tray temperatures are controlled individually on a continuous system, and in a batch system we control them also. But it means that the product at different stages in that drying process don't have to be heated up to the point where those volatiles come off.
Okay. There's several interesting questions, Greg. So what's the minimum pressure you may use? How do you prevent the plasmas?
Well, we have a bit of patented IP associated with avoiding plasma situations that others have challenges with.
Yeah.
And it really has to do with the non-gas dielectrics that we use for guiding our waveguides. And that's one issue. And the absolute lowest pressure we can get to is we typically don't like to get below a Pascal or two in pressure, and we usually stay above that.
What's the effect of microwave drying on shelf life of sensitive materials or on probiotics?
By removing water, we essentially extend, we reduce water activity, and reducing water activity reduces degradation. So typically you can get 6 months to multiple years as similar to dehydration through freeze drying.
Yeah. And I can say that for some of the high sensitive products, as long as we keep it less than 50 degrees centigrade or 40, 45 degrees centigrade, it's not going to have any effect on these components. So we'll provide a much long-term stability and possibly like much higher performance.
Right.
So will the overall process denature enzymes such as chlorophyllase or polyphenol oxidase? Would the vegetables still require blanching? Like, can you comment on that, or what's the overall fruit?
Sure.
Vegetable?
And this is where the batch systems come in to be particularly interesting. We can go through, by varying the pressure and the temperature in the machine and in the batch process, we're able to heat process at a higher temperature at the beginning to denature an enzyme if that's a temperature you need to reach, and then change the vacuum in the microwave level to then engage in drying. We can do that step partway through the drying process, at the beginning of the process. It really just depends on what makes the most sense for that particular product.
Okay. And how does the process affect structure of compounds like proteins? I guess it depends on the type of protein and the type of application. It's a very broad question, but depending on the temperatures that you can apply, I think we may have quite the functionality present, I assume, right?
Oh, yes. If you stay very low in your temperatures, and your temperatures are, say, in the 33 C range, that's pretty close to what you get for your crops out in Saskatchewan in the middle of the summer.
Exactly.
So enzymes aren't being destroyed in those crops in the drying process. But if you chose to heat your product up to like 75 or 90 degrees C and then dry it, you could denature those proteins. So it really depends on how you want to develop that recipe and that solution.
Yeah. Besides drying, is there any other application that you can use this technology for, Greg?
Yeah, there are lots of applications. We're doing microwave assisted biosynthesis. All sorts of different applications are coming to us. And that's the fun part of the job right now, is because we're just entering into this market. We see material manufacturers from different industries coming to us, and things we had never thought about doing are coming to us on a daily basis. Good,
great. And can you discuss, like, compare CapEx, OpEx with your system versus spray drying? I know you showed that slide, but if you look at, like, in terms of the really a number, like a value dollar, a spray dryer versus like a Titan?
Yeah, so I'm happy to go through that on a as an individual basis once we know the size of the application. So what we had done in that deck was basically take our Kraken 60, which is a 60 kilowatt drying machine, and compare that from its throughput to what a freeze dryer would do in a day versus what a spray dryer would do in a day. And so we looked at CapEx, footprint, and the installation costs. And we've been consulting with engineering firms to try to get those numbers as accurate as possible. And that's why the actual CapEx for our systems is really quite great, even though the sticker price of the machine is a little bit higher than you may have an air dryer. By the time you factor in the actual installation and the downtime that these other processes have to ours, we become very competitive. Nothing quite like having a machine roll in a day or two and operational in a day or two.
Yes.
Customers really like that.
Yes. And the last one is like what type of in-process data generated for each run? I assume it's like complete.
Everything.
Everything.
I never met a sensor I didn't like and I didn't want to track. So the database is huge.
Yeah. With that, thank you so much, Greg. We really appreciate it. We had over like 18 questions. It was a very valuable webinar session. Again, on the screen, you can see information, email, and contact information for NuWave. Please feel free to reach out to Greg and his team. And again, I look forward to having you for trials or other activities at the Food Center too. Please reach out to me and the Food Center team as well. Thank you very much. Wishing you a great long weekend. Thank you.
Thank you. It was a pleasure being here.
Thanks, Ray.